We now get to work on rounding and estimation. Now, if you consider somebody who has a bank account, has $528.33 in there. That's what the bank will put because they have to be exact. However, if they were to tell you, bragging about how much money they had in their bank, they might say, I have about $500. Most people would think that they made an accurate statement. Yeah, that's around $500. If you're really nitpicky, you might think, I don't think you're exactly right. That's the whole point. This about gives you some leeway. Says, we're getting in the ballpark. So, you could also say, I have about $530. Also a correct statement. You could say, I have about $528. Now you'll notice that at each stage, we're closer to what the real value is, but we're not exact on any of them. We're still about. You could even say, I have $528 and about 30 cents. Anytime you're saying any of those, you have rounded. You've said, you know what? If you are counting by hundreds, and somebody only understood in hundreds, 100, 200, 300, 400, 500, 600, well, this is somewhere between $500 and $600. And you're really headed off to the nearest hundred. So if you look at these places, here's the cents or hundredths, tenths, ones, tens, hundreds. And right here you're saying, okay, if everything else behind that is 0, what's the closest? A 5 or a 6? And that's where we get this 500. If you're rounding to the nearest tens, that's hundreds. Here's the nearest ones, because it's to the nearest one whole dollar. This is to the nearest tenths, or tenths of a dollar, a dime. So we've just taken this number and rounded it. Now you may wonder, why would you round in the first place? What is the purpose of rounding? Well, as you did your multiplication tables, there were a couple of them that were nicer than the rest. So we're going to go through and tell you why rounding would be so good. Rounding is valuable, particularly because, if you remember, you had something like 15 times 11, and you're like, okay, 15 times 11, you had to memorize what that was. 15 times 11 was 165. There were some patterns that you could pick up, but not necessarily easy. However, 15 times 10, you're like, 150. And 14 times 10, 140. It was really nice because this thing right here, all it did was add a 0 to everything. That's what all the tens did. And so we come in, if we have something like, okay, 528 times 39, we're like, oh, that's going to be kind of a problem. If you don't need to get a precise answer, and you're okay with an about, then you're able to round and get about an idea. So this is about 500. If you were to round to the nearest hundred up here, you have 500. And here we have 39 that's about 40. Right here, if you round to that nearest highest place right there, that becomes a 4. The 9 takes it up to a 4, and you get 40. Now this becomes really easy because you know 5 times 4, that's a 20. And then you add a 0, add a 0, add a 0. It's about 20,000. You should note that we haven't really done the math. We've just got an approximate answer. Kind of helps to know whether or not when you do this problem for real, it's going to come out kind of close to 20,000. That's the idea of rounding ahead of time so you can estimate later. This is the process of estimation. So let's make sure you've got down where the places are. There we go. From the decimal point, if you go this way, you have eighths would be a portion of a whole number. That's why it's behind the decimal place. So here you have the whole ones. And they don't know what else to call that. Some people call it the units or the whatever. If you're talking in dollars, that's how many whole dollars you have. If you're talking in inches, that's how many inches you have, or feet, or whatever unit you're dealing with. That's why they call it the units digit. So here is the tens. So that's how many tens there are. That's how many hundreds, thousands, 10,000s. This is how many 100,000s we have. This is how many millions, 10 millions, 100 millions, and billions. Going the other way, there's the tenths, hundredths, thousandths, and 10,000ths. So this will help you with the rounding to get it to the right place. To remind you of the rules, if you're going to the nearest, in this number, say the nearest 1,000, you will notice that you have like, 6,423,817,293, blah, 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 blah. So this is 817,000. Now, that means you're 817,000, 818,000, and you're somewhere right in the middle. How do you know which ones it's closer to? Well, right smack dab in the middle would be exactly 500, between 17,000 and 18,000. So you look at this number. If this number has a 5, then you're half or higher. If it's not, then you're closer to the 17,000s. So you check out this number right here, 5 or more, this goes up to an 8. 5 or less, this goes back down to the 7. And so rounding at the nearest 1,000 would be, and the rest is just zeros. Because that's what we're doing, we're getting to closest 1,000. So, to review on estimation, you're going to round to the highest level place and then do the easy problem. We're not going to get into the actual multiplication and division until next week. And so right now we just want you to be able to estimate things. For example, if you have a problem where you are saying, okay, I have a job that's going to pay me $423 per week. And there are 52 weeks in a year. How much money am I actually getting? 423 times 52. Well, you estimate and you say, okay, 400 times 50. And again, 5 times 4 is 20. 1, 2, 3. You're going to get about 20,000 per year. So these kind of problems are very handy that way.